Today we have a really exciting topic to go through. We're going to talk about trusted execution environments. And joining us, we have a good collection of presenters. So from our side, you have myself, Nick Gasky. I lead client enablement and customer success at Kaleido. And then we have one of the co-founders, Jim Zhang. He's also our lead of protocol. He's going to walk you through some of the privacy features, specifically on Kaleido, zero knowledge proof, some of our off storage, privacy preserving patterns. From Intel, we have Eugene. So he's going to take us through Project Avalon, SGX, and just some common usage patterns for TEs. And then at iExec, we have John Charles, JC, and Eric to talk you through some commercial use cases, some of their bleeding edge initiatives and AI and climate, and then the Trusted Compute Task Force as well. So I'm going to start by just ripping through a few intro slides on Kaleido, just give you a little context of what Kaleido is, what services we have, and then we'll transition to Jim and subsequently to Eugene and JC and Eric. So what's Kaleido? So Kaleido is a digital transformation platform. At a very, very high level, we sort of have three core tenets that encapsulate Kaleido. Built for modern business networks, and we'll see when we go through some of the use cases and some of the customers, that it's really industry and use case agnostic, have a really eclectic, various mix of, huge Fortune 50, Fortune 100 companies, working across supply chain, working across healthcare, trade finance, et cetera. Our platform, we've put great effort to make both the interface and the backend, the programmatic layer, radically simple. So quite intuitive, but there's also a clean, simple REST API for every single CRUD operation that's available in the platform. And then lastly, really, really important to us in this space, it's very much built for the enterprise. So a lot of features that help support privacy, help support identity, help support, performance, scaling, et cetera. One thing that we've noticed over the last 6 years in the blockchain space is that, the blockchain itself is incredibly important, but it's actually a very, very small component in the overall tech stack. We see a lot of requirements for a lot of the ancillary services, whether it's storage, whether it's privacy, whether it's identity, key management, you name it. So we've modeled Kaleido out to be, yes, blockchain as a service, of course, but more likened to perhaps a cloud catalog where you have these plug and play deployable services that can answer all those different requirements that exist in your use case and in your stack. And the way we see a stack is, really, really quite broad here. So we have different requirements around data. What goes on chain? What goes off chain? What type of transactions need to be invoked on the blockchain? Can they be public for everyone, or do we need to use different node clients and privacy techniques like Quorum or Hyperledger Besu, for example? Then we have the middleware, this critical connection to your back office processes and integration with, hardened and expensive and, legacy cloud estates. And then you have the application layer where we've done a ton of really exciting, a lot of exciting work on Kaleido, in tokenization with zero knowledge proofs, but also with the simplification of your entire application architecture. And we've covered all these features on previous Tech Tuesdays, and I'll draw your attention where to find those and where to get more information about all these services. So our goal at Kaleido is really quite simple. It's to accelerate your adoption curve, take you from POC to pilot into production without all of those hindrances, without all of that friction. And we do a lot of different custom work with clients. So we have different packages, we have different approaches and different techniques where we can structure, bespoke resource packages based on your needs, or even potentially, work with you in tandem, sort of in the role of an SI or, an application architect. Enterprise grade, I mentioned that at the beginning, and this is not hyperbole. We've built a ton of the core features as first-class citizens into the platform. So you have ISO 27001 certification, SOC 2 certification, tons of really, really exciting work in the key management space, whether it's keeping your private signing keys in a cloud HSM, for example, or using master encryption of your node if you want to hold your keys there. A ton of work in the enterprise identity space using PKI constructs and X509 certificates. And then a lot of just great sort of inherent features, HADR, auto scaling, backups, et cetera, that are just built directly into Kaleido. And again, these have all been covered on previous webinars. Just a quick snapshot of that diverse client list that I mentioned. So we can see, retail, entertainment, we can see, banking, oil majors, traders, et cetera, even some government entities as well. Ripping through the final things, Kaleido's multi-cloud, so we support AWS, Microsoft Azure deployments, and even on-premise deployments. So if you have that InfoSec requirement to have a node in your own DMZ in your data center, Kaleido can support the entire combination of this, and this really allows for these diverse, very modern business networks and consortia to be built. Also multi-protocol, so using the enterprise Ethereum variants, but also support for Corda OS as well on the platform. And then again, just one of the final slides here, built with so many APIs, built with all of, the core building blocks right there in the platform, so that you can really focus on your business logic, you can focus on your network, and you can react to what's changing in your industry and in your ecosystem. Onboard new members, offboard new members, deploy new nodes, run cron jobs, automatically instantiate new smart contracts, etc. And really at the end of the day, what we are is, as I said, digital transformation platform, but consortia as a service, making it very, very easy, like I said, to add new cloud configurations, to add new cloud providers, to add new members to the platform and use role-based access control to, allocate admin permissions or even rescind permissions. And all of this is incredibly simple to do inside of the Kaleido platform, and it's also automatable. So again, there's an API for every single piece of functionality inside of Kaleido. And then the last slide, I'm going to stop on this one just to give it over to the actual SMEs here. But if we break Kaleido down into 3 different tiers here, this is where it becomes really powerful and really unique. So starting at the bottom, maybe the member planes, this is where you have full unilateral autonomous control over integrations to your back office systems, over cloud integrations to your AWS or your Azure account, over your own key management techniques, over any services that you've deployed onto Kaleido, whether it's a storage service, whether it's a zero knowledge service, whether it's a token service, for example. Then you have this collaboration backbone, right? This is where we're going to use, of course, the blockchain and our smart contracts for our shared ledger. But then there's a lot of other exciting, what I'll call ancillary services in Kaleido, encrypted end-to-end transport for private messages or lightweight JSON payloads. And this is where it's very easy to have the blockchain sitting right there as your trust anchor, as your source of truth, but then have all of the other constructs surrounding it that really let you extract that business value. And then the last one is the control plane. This is where it's very easy to do that network governance, onboard, offboard new members, add new clouds, have this shared line of sight for smart contracts, etc. Okay, so that was a lot of slides. I don't want to go ad nauseum onto Kaleido. Like I said, we've done a lot of these in the past, and these are all recorded. So final pieces of admin, if you just visit YouTube and search for Kaleido Blockchain, we have curated playlists of every single piece of functionality in the platform, cloud HSMs, wallets, key management tokens, REST API gateway, you name it. And then the last thing I'll mention is that it's free to sign up to Kaleido. So just go to kaleido.io, click get started. It takes about 30 seconds to create an account. And in a few minutes, you can have your own bespoke Corda or Geth POA or Quorum IBFT network. And you can immediately get started with deploying a smart contract and not even having to use a SDK or a Web3 library to interact with it. So highly encourage everyone to just ask any questions, use the chat, use the Q&A. We have a bunch of folks on here moderating, so you'll get a response. Or if you're really brave, just raise your hand and you can speak out loud. So I'm going to stop sharing. We'll turn it over to Jim. Following Jim will be Eugene from Intel. And then after that, we'll have the iExec folks.
Thanks, Nick. That was great introduction and overview of Kaleido. So that's the whole platform. Now I'm going to use a few minutes to focus on the privacy technologies and specifically what Kaleido is doing, so that this will set up the stage for the real start of today's show. Eugene from Intel and Jason Eric from iExec to specifically talk about one of the privacy features involving TE. So as Nick said, within the enterprise, when you have to join a consortium with other enterprises to do a business network, all the concerns that you have to do from your own IT's perspective still persist in the enterprise blockchain network. Privacy and permissioning, scalability, reliability, performance and data control, all of that needs to be taken care of. So today we're going to just focus specifically on the privacy. So in terms of when given different requirements, how you approach privacy, there are many aspects, and they're not competing technologies necessarily. Each solve a kind of a different problem. Some of them can be applied to fulfill the same requirements, but oftentimes they sort of work together to solve a business problem. So we have identity masking techniques that allows a transaction to be signed by a different private key every time, so no one can trace your transaction history and figure out who you are if you don't want to disclose your identity. And then as far as keeping the business data private, so only the transaction parties are able to see, and others, if you're not part of the transaction, you're not supposed to see. For that kind of purpose, we've got different technologies. You can use different instances of blockchains to completely isolate transactions. So if you want to see the data, you have to join and be permissioned to join the blockchain. Or within the single instance of a blockchain network, you can use private transactions where on a transaction by transaction basis, you can designate who are the subset of parties that should see the transaction data, so that no one else, if you're not part of the direct parties of the transaction, you don't get to see the data because you don't have the decryption key. Other techniques involve actually doing the transaction off-chain instead of on-chain. So business information are exchanged peer-to-peer directly from within parties, and they're end-to-end encrypted. But blockchain is still used even in that case to protect the data. So the property of data immutability of blockchain is still utilized in that case to make sure data cannot be modified even if they stay off-chain. And in terms of some of the more leading edge technologies that are gradually being adopted, zero knowledge proofs and trusted execution environment, which is today's focus, plus secure multi-party compute. All of them are based on advanced cryptography and is getting more and more adopted. So in terms of how these different kind of technologies compare, we have two axles. On the x-axis, we've got where does the data exist. On the right-hand side, all the data goes on chain. On the left-hand side, we keep all the data off-chain. The y-axis shows you where processing or data processing logic happens. So computation can be done either on-chain using smart contracts or chain code or core dApps, depending on which protocol you're using, or they can be done off-chain. And isolated blockchain, obviously, the computation is done on-chain with smart contracts. The data itself goes on-chain as transactions. Identity masking wallets applies everywhere. And then these off-chain technologies with private transaction managers and off-chain data and message exchange, they're completely off-chain, and both the data and processing are happening off-chain. Blockchain is used to protect the data that are exchanged off-chain. And then zero knowledge proofs and trusted execution environments are kind of similar in that they keep the data private. So no data goes on chain when you use these technologies. They stay off chain. And processing of it, there's two sides of the processing. The generating, the actual processing of moving the state transfer, and also presenting a proof of your off-chain compute so that the proof can be sent to the other parties to verify. So you've got a combination of computation happening off-chain plus computation in terms of verifying the proof, that's typically happening on chain. So instead of sending any real data to the blockchain, the proof representing the computation is sent instead to the blockchain, so that all the parties can verify that the computation has been done honestly. So that's sort of the landscape in terms of where data exists and how computation is done. Now, getting a little bit deeper into each of these technologies, identity masking or hierarchical deterministic wallet, it's a way to have a single master seed and derive like billions of signing keys. If you didn't have access to the master seed, all these billions of signing keys would appear to you as random keys, that they were generated and completely independent of each other, and they're completely random, even though they were all derived from a single key. So this is using cryptography to do key derivation, and the value is they just look completely independent. So you are able to hide your trading patterns, hide your transaction histories, so that the patterns of trading history cannot be traced to a single entity, and as such have privacy leak. This is very easy to understand. If you want to keep your data completely isolated, you just create separate instances of blockchains and invite only the parties that are parties to the transactions that they should see the data for. Private transaction managers, this is a technique pioneered by both the JP Morgan Quorum team, but also Hyperledger Fabric team, to have a transaction that's targeted to a subset of the participants in the blockchain network by using encryption. So unless you have the decryption key, you won't know that this transaction is meant for you. And transaction payload after encryption is only sent to the direct subset of the parties. And blockchain in this case is used to protect the data off chain using a hash. So everybody gets to participate in protecting the blockchain with the hash, protecting the transaction with the hash on the chain, but the actual transaction is exchanged off chain. App-to-app messaging and data exchange are very similar in that, in fact, they're pretty similar to the private transaction managers pattern, in that the business transaction data is exchanged off-chain using end-to-end encryption. Blockchain is used to coordinate the events, but also to protect the transaction data using a hash. So Kaleido has support for all these technologies as services you can provision from the service catalog that's available on Kaleido. So now let's talk about trusted off-chain compute. It's a technique where the transaction data is hidden, so that you don't get to see the information that's involved in the transaction unless you're a party of the transaction. But the processing logic is known to the whole network, so that when a proof is presented, everybody is able to validate that the transaction has been done correctly or honestly. So the idea is that I may not know what you have done, but I can be convinced using the attestation or the proof that you did it honestly and correctly, and there's no cheating. So zero knowledge proof falls in this category of off-chain compute. Using cryptography, a computation is done and the proof is generated along with the computation to allow the verifiers to be convinced that the computation was done properly. So you don't have to know exactly how many tokens get transferred from one party to the other. You just need to know that the entire token supply has not been altered as part of the transaction. And that's all you care about as a observer of the transaction. So Kaleido has a zero knowledge token transfer service. It's one of the services that we support in terms of privacy, where your token exchanges and transfers can be done with zero knowledge proofs. So only the receiver and sender knows how many tokens get exchanged. All the others can only verify that the token happened according to protocol and no cheating happened. So it's a very easy to use service you can provision on Kaleido. And finally, trusted execution environments. This is using hardware to have a secure area of the memory where only the CPU can access, so that only even if you are able to hack into the system and you gain access to the operating system, so you have access to the memory and you do a memory dump, you still don't really know what's going on inside that special protected memory area. It's called enclave. So both confidentiality and integrity is protected with this technique. And Intel, with the SGX technology and recently AWS with Nitro are some of the leading technologies in this space. And without further ado, I'm going to hand over to Eugene from Intel to tell us more about SGX and Project Avalon. Over to you, Eugene.
Thank you, Jim. Let me just share my screen. Okay. Hello, everybody. Well, first of all, I would like to thank you, Kaleido, for giving this great opportunity to present the Hyperledger Avalon open source project to this community. So today, I would like to talk a little bit start by very briefly introducing the Avalon, then talking in a little bit more details about the confidential computing and using the trusted execution environments, and then talk about the background and usages that we use, was the goal why we actually started the project, and a little bit touch on the architecture of the Avalon project. So first of all, a few words about the confidential computing. That word is actually really in my mind, is a new frontier in the protecting the data and execution. We already have a lot of practices protecting data at rest and in flight, but we do need protect data in use as well. And that is actually where confidential computing comes to play. There are a number of ways to look what is actually confidential computing, and it can be broader view, like Jim presented that using the different techniques. In my presentation, I will talk a little bit more narrow view. I will use the definition from the Confidential Compute Consortium. Confidential Compute Consortium is a Hyperledger sister organization that is in the Linux Foundation. And with that, so the definition from that organization, that confidential computing is really the protecting data in use using hardware-based trusted execution environments. What it really means that we're trying to protect the data from the malicious insiders, from the external attackers, and from the unauthorized third parties. The idea here that you, in case of, for example, SGX, you would load the trusted library inside of your application, and it's protected by the hardware, by the CPU, in a way that neither the other applications, no operating system or VMM cannot actually see the data, or even if you want the code inside of the that enclave. And even the application that loaded enclave technically cannot really look inside of the enclave, even though it can communicate in a particular way with enclave. And so to summarize, the enclave can be created by the user mode application at any time. It's isolation from all other software components running on that platform, and it has a built-in attestation mechanism that allows to verify that right software runs on the right platform. Also, in case of the trusted execution environment, the data usually protected within the boundaries of the CPU. Data are encrypted when they go outside of the CPU, and they are encrypted and the integrity checked. So that is actually substantially increases the likelihood that this data is going to be seen only encrypted by the reads and snoops on the bus. So that is actually provides the protection outside of the CPU boundaries. Few words about the attestation. When we talk about the enclaves, in some cases they can have value on its own without attestation. So they can be used, for example, CSPs to improve their internal security practices. But in our case, we really want to utilize the establish a trust model between the smart contracts running on blockchain and between the software running inside of the enclave. So that is where the attestation comes to play. So first of all, we deploy the signed code on the remote platform. And at that time, the enclave is created and measured against the signed code. And that is actually by the hardware, by the CPU. And that is the starting point. So at this time, we have the enclave that started. The next step, what is actually the enclave can do, it actually can generate the attestation, and that attestation includes the platform-specific keys to sign it, and that attestation information can be communicated to the relying party or a requester for the verification. And at that point, the requester can verify and make sure that the data provided by the enclave is actually number of things can be verified. So one of them that this is a genuine platform running the actual enclave. And then this is the it's a TCB at right stage, and it really runs the right expected software inside of the enclave. After that, you can establish the authenticated channel between the requester and the application, and the data can be securely exchanged between the remote party and the enclave. So now I would like to talk a little bit about the project itself. So very briefly, what we're trying to do with Avalon is Hyperledger Avalon is to extend the computational trust beyond the blockchain itself, but go to the outside of the blockchains and make sure that we can rely not only on the institutional trust to the compute done outside of the blockchain, but also on the computational trust. And for that, we actually use the SGX trusted execution environment. And obviously, we rely heavily on both the properties of the enclave itself and the ability to attest it. So our goals is improve the blockchain scalability and confidentiality, because we can either to execute only once a few enclaves instead of the running on the whole blockchain, or we can actually maintain the data, protected within the outside of the blockchain itself. As I mentioned, that the project is actually relied on the trusted execution environments, and it's designed to run side by side with blockchains. It's blockchain neutral, even though we utilize the specification that has been developed by the Enterprise Ethereum Alliance. The specification written in the context of the Ethereum blockchain, but it's actually applicable to different blockchains. And we already have implementation for both Ethereum and for the Hyperledger Fabric. As you can see that there is this greenhouse, the Hyperledger. Those who are familiar with a Hyperledger organization knows that this is how the projects are organized within the Hyperledger. So they maintain the number of different projects. At the top, this is a different blockchains. And at the bottom, the different categories, the supporting projects. So the Avalon fits in the category of tools. So this is a Hyperledger project. It's actually had a broad number of companies supporting the project at a time when it was created and the list in the blue box. I have to mention that the Kaleido and iExec were among the very strong supporters of the project from the very beginning, and they not only supported the project itself, they actively participating in the development of the specification itself. So now I would like to talk a little bit about the usages that we're trying to enable in our project. So first of all, let's look how the your normal application works. Normally blockchain application works in the business environment. So we have a blockchain. We have couple enterprises A and B, and they would communicate through the blockchain. They execute the smart contracts and perform their specific logic on blockchain. Each node would execute the that logic and maintain the copy of the data. This is the model, the traditional model of the blockchain execution we all used to. So what we're trying to change a little bit here is we assume that there is a trusted compute service. And that service shown here is a separate from enterprise A and B. In practice, it can run on enterprise A or B, or actually on each of them. And the execution can happen depending on specific case in different environments. The key here that enterprise A and B can execute the complex workloads or workloads that require special security properties, that trusted computing service, and then the blockchain in this case can be used to maintain the receipts or cryptographic proofs of the execution. But the data themselves don't have to be shared on the blockchain, and the execution doesn't have to be done on the blockchain. So in this case, we can achieve both confidentiality and scalability because we don't have to execute the same code on the every node in the blockchain, and we can execute much more complex code and potentially any code that is not necessarily can be executing within the smart contract on blockchain. So a little bit go to more specific cases. So let's look at the privacy preserving the COVID-19 tracking. So, and that is, by the way, is real application implementing the by number of companies. It's not like the theoretical, even though this is kind of like a generic model, but this is really was implemented. So in this case, what we want, we want to make sure that we monitor the track the people and analyze the potential that they get contact with infected people and may be infected themselves. So we have three categories of actors. That is individuals, and we assume that they use, for example, their cell phone data to provide the information about their locations. There are hospitals that report the infection cases, and there are, let's call this a CDC or any other organization that actually responsible for the monitoring and identifying people who are at risk to be infected and, for example, go to be tested. So the important part here that communication happens through the trusted execution environments. So we can actually send a lot of transactions. The data is going to be maintained in the tracking database. So the individuals send their data, but nobody knows about their location because that kept encrypted. When hospitals send the data about the infected people, again, this data is encrypted and known visible only within trusted execution environment. And specifically design algorithm allows CDC only to have names of the people who actually were infected. And in this case, they know to who notify because they may be at risk, but CDC does not know where these people were, what was actually the travel history was. They just know that those people can be at risk and should be notified. And blockchain may serve that as an arbiter to maintain the proofs and statistics to keep the application honest. Also, probably will skip this one. I would like to talk a little bit about the attested oracles. Oracles, obviously the important part of the blockchain applications because they allow us to interact with the external world. There are a number of different types of oracles, and here I kind of like divided them in 3 different categories. So the first one, we sometimes need the execution that we cannot do normally on the blockchain. For example, generating the random numbers. And that is actually these verifiable algorithms. They run in the mostly in isolation and provide some valuable information to the blockchain. The second group is actually connecting to the legacy applications. So in this case, we can trust that the data execution came from the trusted execution environment. The enterprise may, for example, provide a proof on blockchain of the data that is going to be used to perform the queries. For example, it can be cryptographic proof of the bill of materials, or it can be some other data that fixed in time. And then when the request executed on the trusted execution environment, we can trust the algorithm that runs inside of the trusted execution environment. We also can be assured that data that used to process the queries were actually done on the expected data set. And finally, the trusted intermediary. We have the external data sources, and those from those sources, we may want to send some events to the blockchain. For example, if the price of oil goes above some threshold or below some threshold, or some weather information, all kind of information. So again, using the trusted execution environment here allows us to make sure that connection actually was done to the right service, the right credentials were used for that, and that right algorithm was used to uh, compute the required the event. So this is the examples of the tested oracles that we may want to look into, and we have ability to implement using the Hyperledger Avalon. And the few words about the architecture of Avalon on this diagram. So there are fundamentally 3 parts. One of them is a requester, that is on the bottom left corner. There is the blockchain that runs the smart contracts, and there is the trusted compute service that executes the bulk of the Hyperledger Avalon code. There are 2 ways for the requester application to connect to the trusted compute service. It can be done through the blockchain, or it can be done directly through the JSON RPC listener. And the reason for that in some cases we have to deal with regulations. And when we have to do with regulations, we not always can send data to blockchain because the nodes of the blockchain may be distributed across different geographies, and the regulations don't allow to do that. Also, we may have a high stream of data that would be too hard for the blockchain to process. So in this case, we can actually send the data to the trusted compute service, and trusted compute service can process them, and then is actually providing the cryptographic proof on the maintain these on blockchain on the batch data. So I'm not going to go through all details, but effectively we maintain the registry that provides the information about the work orders and about the worker registry. So that is really the mechanism that allows us to execute the work orders in the asynchronous mode when the request sends through blockchain, and the requester can freely submit a request, go away, and then check for results later. We have the orchestration mechanism that runs worker microservices. And also at the end, I would like to point out to the coloring scheme used here. So the blue items represent what is the common infrastructure element implemented by the Avalon, and the red items is actually, or orange items represent what is actually application specific. So fundamentally, you have 2 parts. One of them is your requester application. It's not necessarily going to be completely new, but it can be extended to be able to take advantage of the utilizing the trusted execution environments. Obviously, the code, the algorithms that run inside of enclaves has to be developed. That is the workload. And what is not shown here, technically it's not required. The blockchain can rely on the existing contracts that already exist. But also, even though it's not shown here, the smart contracts can be modified and or additional contracts can be created, obviously, to extend your application. So I think at this point, I probably will stop and let the JC to go on with explaining what they're doing at the iExec with the trusted execution technology. Thank you, guys.
Thanks, Eugene. That was fantastic. All right, JC and Eric, over to you guys. And just a heads up, we can keep going after the top of the hour, and this is recorded, so all attendees will get an email with the recording, and we'll share the link to our YouTube page as well. So take it away, iExec.
Hi everyone, thank you Nick for having us. Thank the Kaleido team. It's really cool to be here today with you. So I am Jean-Charles Cabelguen, please call me JC. I am the Chief of Innovation and Adoption at iExec, and I will be also with Eric Rodriguez, with a Solution Engineers and Product Owner at iExec. Before diving into what iExec is, I would like to share with you a timeline regarding what has been done previously inside the company. So we come from a background in distributed and cloud computing. We have worked 15 years in that field. iExec has been founded in 2016 by Gilles Fedak and Raoul. And the idea from the beginning was to see how blockchain technology could add a value to distributed platform and to distributed systems. So in 2017, we did an ICO. It was enough to fund the company, to recruit highly skilled developers in order to develop the project. During the four years, we have worked on being sure that we were able to provide what has been presented inside the white paper. So we released 5 versions, and mid of 2020, we were really pleased to complete the white paper, to achieve what has been presented before the ICO. And we are really pleased about that part. And what is also really interesting is to say that we have completed the white paper. So now we are on the second part of the life of the company. And that part is really focused on the adoption. The first indicator, a really strong indicator of the focus of iExec on the adoption, is the French SEC approval for regulated marketplace. So in France, we have the AMF with the French SEC approval and the French SEC. And we received in September an approval from this entity in order to allow us to present regulated marketplace. So it's very close to what iExec has been developed during the four years. And the idea was to say that we want to be closer to the needs of the companies in providing a marketplace that is regulated and compliant to KYC and AML. Here is a presentation of what iExec is. The main idea is to say that we want to connect everything that is digital to people and to companies and to consortium that want to buy and use that. When we say everything that is digital, it's data sets, it's applications, it's also CPUs or GPUs. And when we want to match the request of companies or consortium to data sets, to application or to CPU or GPU, we have to have a middle layer. And this middle layer needs to be able to provide trust, to provide privacy, and to provide governance as a triptych in order to provide efficient services. So that's the role, the main role of the iExec marketplace. As described in the middle of this slide, we want to be able to manage the access of the control, to monetize the service that are provided, to be sure that it's possible to automatize the payment and the reward. And everything is based on the pay-per-task model. So the idea is to say that it's possible to have a recurring business with the providers of a solution, but also to have a one-shot approach. And that's really interesting when we want to have an efficient and a flexible business model. So maybe to illustrate, if you are a consortium of companies working in the retail industry and you want to create an AI model that needs to recognize, for example, how consumer is using a specific product, you can use what you have already in store, the data set you have, but you can also have access to data set from other companies, maybe from competitors, and leverage what has been developed by them in order to train your AI model. The idea is to be sure that you will pay based on the result of the computation, and you will have access to data sets from other companies really based on what has been validated before the start of the deal. And I will go here into some use cases for providers. If you are a provider of application, the idea is to be able to Dockerize your application in order to monetize it. Your application could be AI application, it could be a scientific application, it could be a business-oriented application. The idea at iExec is always to be hardware agnostic and also software agnostic. So the minimum requirement is to have a Docker image. You can provide a set price, and depending on how the business is evolving, being able to adjust the pricing you have already set. Yes, there is no vendor lock-in, so the idea is to really provide a flexible way to your customer to leverage your application. For data providers, the same idea is to be able to monetize AI model or data set that are not easily tradable or shareable today. When you have the chance to own really valuable data set, it's possible to use an end-to-end encryption model based on trusted execution environment. Previously, Eugene has explained the main key feature of this approach. The idea is to leverage software encryption, but also hardware encryption, for example, in using IntelliGX. The same again, if you have, as a company, CPUs or GPUs that are available, the idea is to easily connect those resources to the iExec marketplace and to monetize them when you want, and you can switch off or switch on regarding the need you have and the availabilities you have. On the requester side, what we want at iExec is to make it as easy as possible. So the idea is to come with your own code, to leverage the services that are possible thanks to the providers, application, data set, or computation. So you can run your own apps using a data set from other companies, or using CPUs or GPUs from other company, and that the marketplace of iExec will manage to find the best price regarding your requirement, your business requirement. Here again, what is really important is to have a trust in the process. So what we have developed at iExec, it's a protocol called POCO, Proof of Contribution. You will pay only based on the result you will receive. So the POCO will manage and will evaluate the rightfulness on the result you will receive. And based on that, you will be rewarded. You will receive the result, and the provider will be rewarded. At the opposite, if the result that is provided is not right, the POCO will automatically decline the payment, so you won't be charged, and the provider will lose some money in the process. The same here, if you want to have a high level of confidentiality, we can automatically provide a trusted execution environment solution from A to Z, and be sure that the services you will have access to will be private and secure. So I just wanted to give you an overall view of what iExec is what is the main product of iExec, this decentralized marketplace. The key ideas is to say that it's hardware and software agnostic. We want to present dataset, application, and CPU, GPUs as commodity in order to be sure that we can trade them easily. And we have developed this middle layer in order to allow that concept. Here, I will let present Eric the iExec product in order to illustrate what we have in parallel of the marketplace. And then later, Eric will also illustrate some use cases, business use cases, and we will also present to you a demo. Eric, you are on mute. Eric, you are still on mute.
Sorry, thank you, Jesse. Okay. So now let's take a tour on the iExec product. So there are many, we have many different products for iExec. The first one is the marketplace. It's very similar to trading services when you have an order book and you can see. You can trade your digital assets, and you can see the variation of price, etc. You can interact with the marketplace. We also have more user-friendly front end. We have a DApp store and data store. You can anyone can directly select his own application and his application and dataset and directly trigger a computation. iExec allow also to provide and build oracles. For example, Kaleido, a well-known on-chain blockchain data provider, propose his own price feed for the DeFi space. We also, as Jesse introduced, we also now have a marketplace for enterprise, which is very close to the existing marketplace. So we received an approval to issue an equivalent token, the ERLC, which is equivalent to our current token with KYC AML compliance. And of course, we have excellent tooling for developers with a full and complete SDK and an explorer to monitor everything on the marketplace. About deployment, we are live on mainnet since 4 years now. 2 or 3 years ago, we set up to more than 200 workers on the public worker pool. It was a great achievement. But as you know, the gas now is very expensive. So we also propose a sidechain where there is no gas and it's a little bit faster and you can interact with the marketplace with all the feature of iExec on the sidechain without paying gas. And we can also, that's the magic of the blockchain, and you can play Lego with our stack. We can imagine to create and to be a kind of third party for Kaleido, for consortium, private blockchain, and you can here plug and develop your own digital asset marketplace based on Kaleido ecosystem. I will be fast on that topic. Yes, of course, we are off-chain computing solution and confidential computing. So we leverage T technology, and we are active in that space. So we participate to the specification of off-chain trusted compute at EEA, and we are also a member of confidential computing consortium. Privacy in data lifecycle. So there are 3 pillars for the privacy. You have to protect your data at rest and in transit. You have to secure data during its processing. So for both, we use standard and we use the most advanced technology. We use T and encryption. But at iExec, we are more focused on managing your data, make sure that you have a strict control of who's gonna use your data and in which purpose, who is the beneficiary of the computation. So we use the blockchain. We are more focused on the blockchain side to create to propose an efficient data management for private data and confidential computing. Use case. Last year, at the beginning of the year, we work on a decentralized marketplace for delivery companies. And the problem was they wanted to share their data and they wanted to put in common their data and extract some valuable information. But of course, nobody wants to share the detail of his commitment in the pool of data. So we propose a DApp and a decentralized that use a decentralized marketplace to allow this use case, to develop this use case. Sorry, and the project stay at proof of concept, but we should imagine to go further and to put the project in a more advanced, more production level. We should think about get an efficient governance for the trust, the privacy, and the data. Who gonna access the data and the computation? So that makes sense to bring the 2 technology, iExec stack and Kaleido stack, to build some kind of solution. Now I'm going to show you a live demo. So I'm going to show you how you can subscribe to an emailing service without revealing your email address. So let's go. We develop a full front end for this. So first thing I have to do, I have to make my email. So now it's not anymore a secret, but I decided to encrypt my email. So I'm just creating a data set, an encrypted data set, and this data set has been settled on the blockchain, and the ownership of the data set is attached to my Ethereum identity. So the data set has been stored, but no one can use it. Now I'm gonna give access to only one application. So I authorize an email service to be compatible with my data, but still no one can use it. The interesting thing is that it's a kind of whitelisting system. So I can go to the code to check the code of the application, and here is the GitHub source code. I know exactly which container it is, which will be used, which it contains, and the verification will be done on chain to be sure that this is this application that will be used. So now, second step, I have to authorize a third party to use my data and this application. So there are only one beneficiary. So only the marketing company can use, can trigger the execution. So let's go. Behind the scene, the magic is happening. The matchmaking is done on chain. So we have data, application, and the trigger, the beneficiary, the marketing company. And also we have the T worker that iExec, that the marketplace proposed behind the scene. And the deal is done. And once the deal is done, the competition will start. So if I go to the Explorer of iExec, I can see that there is a deal that just have been settled on the blockchain. I can go, I have all the information about the application. I can check, for example, for the app, and I have the confirmation that this probably it's my task. So if I wait, if I go back, so the deal is here. I can see that the task has been started, and I just have to wait a few seconds. So all the complexity and all the power of iExec has been used to create a very funny app. So, and that's it. I received the email, and so I received the email from the marketing company that didn't even see my email address. Next steps, as you can see, we can create very crazy app with iExec, and I invite you to go further. And if you are a developer, come test, because we democratize the confidential computing. We propose a very useful step-by-step tutorial, or any developers, it's not very difficult. Any developers can build his own confidential computing app, and it's well explained, very complete. I invite you to test. So if you need more information about iExec, I invite you to go to the iExec Academy, and we have also 2 other demos, very interesting at developers.ex.tc. The first one is about how you can use computing resources without vendor lock-in. And the second one is why oracles needs T, and how oracles must leverage the T enclaves to be secure.
Yeah, thank you, Eric. I would just like to insist on what Eric said. What is really interesting is companies can use information without owning those information. So the illustration of the email speak for itself. And it's today we think that it's normal that company own our information, but I think in the future we will see that as like a weird time to share everything with company. What we want today is to give access to information without losing the ownership of those information. That's why the illustration of the email is interesting, and we want developers to start working on the iExec stack in order to implement their ideas. But for sure, for companies who want to go faster on the track to implement the iExec stack, we're also providing iExec services for enterprise. I won't go into the details, but we have a 3-step way of working with our clients. The first one is ideation and consulting, then development, deployment, and then maintenance and growth. Working with startup and as well with a lot of big companies, we have observed that the ideation phase is really interesting. The idea is to have a 2-day workshop with our clients in order to help them frame their need, be sure what type of technology they want to use, and then help them in order to go further in the idea they want to develop. And for what type of technology, it could be, for example, question as basic as, is it a mainnet? Is it a sidechain? Is it a consortium of blockchain? Do we want T? Do we want T from A to B? Or do we want T from A to Z? That's the type of brainstorm we are doing with our clients. And at the end of this ideation phase, we are providing them a framework in order to be sure that if they want to go to a POC or to MVP or to a pre-prod project, they know exactly what type of technologies they will implement, how long time they really will take, and how much it will cost. Just here for the next slide, Eric, please, next slide. It's an illustration of the partners and the collaboration we have had in the past. I won't go into the details for sure, but feel free to reach us, Eric and I, in order to have more information regarding those partnership and those work we have developed in the past. Thanks for your time. You can contact us at contact@iExec. Also, you can contact me at jcc@iExec. Thanks, Kaleido, for having us. It was really, really cool to be here today. Thank you.
Thanks, JC. Thanks, Eric. Thanks, Eugene, and thanks, Jim. That was really fantastic, and I definitely learned a lot today. Really appreciate everyone that attended. Hopefully this was useful, one of the tranches of presentations. Again, I'll just reiterate, this was recorded, so we'll post this to the YouTube page, and we'll also send out the email. JC just gave you the contact information for iExec. I posted some URLs inside of the chat if you guys want to get in touch with us about anything technical or commercial. And then I'll just drag my feet. Eugene, if you want to leave any contact information about SGX specific questions, feel free to throw that into the chat as well. So again, hope everyone's staying safe, healthy. Another big thanks for everyone that attended, and please stay tuned for some future collaborative presentations coming down the pike with Kaleido and other industry partners.